Okay, now that the channel set is complete, we can move on to the culverts, adding the culverts and setting those up. So let's go ahead and start by cleaning up the map and making sure that the data looks the way that we want it to make it easy to tell which way the culverts are designed to flow. So let's try that here. So what we have is we need to turn these three off because we just want to see the schematized channel, not the user layers. And then we can turn this one on with our elevation raster and then load the data, which is here. So project data, culverts, and then there's just one shapefile in here that we need. So just import that. And all of our culverts will use the generalized culvert equation, so we won't need any rating tables for this one. But the two weirs we had rating tables for, but the culverts will be generalized culvert equation. Now, what we need to do with these is to change the style and labels. So double-click the layer, and let's see. First thing is the symbology, and then you click on this guy right here, simple line, and change that to arrow, and then click apply. And then same thing, switch over to labels, change it to single labels, and structure name is the first one that comes up because it kind of picks something that says name in it, or maybe sometimes it just picks the very first field, and then you click apply or OK again. Now you won't see those labels until you zoom in. Until that label is readable, you won't actually see them. So this is what our structures look like. They are mostly just little box culverts or little round circular culverts. Okay, now let's go ahead and see what's the next step is. So we import the data, format the layers, and then we can see the culverts. And the next thing is to build the structures into the user layers. And now we'll work through step 3 to set up the editor widget and convert the structures that we just imported into Flow2D structures. So it'll be pretty simple. We're going to open the structure editor and click this button right here, and then just start adding the shapes. And I'm not going to follow the exact position of these lines because they're not perfect. So if you watch through this this GIF through the whole cycle, you can see it's got a little timestamp down here. So watch through the whole cycle and see how I kind of pick these structures where the elevation does a good job of representing the invert of the channel, or sorry, the invert of the structure. So let's get back here, and we'll start with the structure editor, and then we'll just click on this guy, and that will just allow us to start adding these structures. So you see I'm using my roller wheel to zoom in and out, and you see this one's kind of on the side, so it's not in the best position. That upstream node is not in the best position. Probably the best one is this one or this one because they'll have the lower invert. Now you can manipulate the elevation on these, so that's another thing to consider. So I'm going to click this, and then if you look down here, kind of the best one is probably not here because you see that's got that elevation right there. We'd have to change the elevation. So I'm going to click this one. We're going to have to probably change the elevation on that one anyway. And then I'm going to right click and enter because I don't need to do anything. There's no attributes that I need to add right then. And this one looks pretty good. Like this one right here looks pretty good. So just go here to here and click OK. These ones tell you kind of the general location of that culvert, but I'm going to show you kind of the desired location. This one here, from here to here is probably good. And this one here, see, it's not any good because it's on the wrong cell. So I'll go here, and then if you look, it looks like it comes out like right about here, not right here. And then I'll right click on that, and that takes care of those 4. Then there's one down here that takes the water from this channel, so I can just click right here. And then on this one, it goes floodplain to channel, so you're going to want to click this on a left bank. So make sure you're on the left bank for the downstream node. And I'm always right-clicking to close the editor. And we'll just grab these last four. I think there's 4 more. This one looks pretty good here. And then here is fine. Right-click. And then this one we can pick up too. This one actually looks pretty good. Two more. So that here to here and here to here, maybe. I'm going to hit delete. I'm going to hit delete twice, and then I'm going to put it right here and then right click. Okay. I think that's it. I think that's all of them. So once you have them all in, all of the box culverts and circular culverts in, you just come over here and you click the save button, and that will list all the new structures, and then you have to fill out the data. So I'll show you. So let's just start with structure 10, and you hit the center button right here, and then just zoom in, and you can see that that structure 10 is also CU10. So we'll see that. We're going to see the data for that in just a second because it's in the culvert data is in here. So I'm going to change this from no, this stays the same, floodplain to floodplain, but just rename this CU10. And it's a rating, generalized culvert equation. So that's this one here. And everything in this area is probably reduce discharge and allow upstream flow. And then we have to do culvert length and culvert conduit, and then these 1, 2, 3, 4, 5 variables over here. And we get that data from over here. So this one, floodplain to floodplain. We have one that's floodplain to channel, but the rest are floodplain to floodplain. And if I right click and open this attribute table, let me just minimize that. You can see that all my tailwater switches are allow Q. All of them are generalized culvert equations. One of them, CU15, is floodplain to channel. And then the rest of these values are here, names, all that. So I'm going to just kind of move this off to the side. Let me get CU10, and then I'll just fill this data in. Okay, so we'll start over here and finishing up on this side. The length is 143.58. And the width, if you tab, the width is 6. And that's a box culvert. And then the type is 1 for box culvert, and the entrance type, I can bring this back over here, is 3. And we'll get to the data input manual, but you'll see that this is like whether or not it has wing walls or whatever the entrance type might be for either a circular or box culvert. N value, and then this is a loss coefficient, and then that's the width. Don't be fooled by this. This label is wrong right here, and it's funny because I've changed it several times, but every time somebody pushes data to the system, it overwrites it with the old method. So I have to get the original programmer to change this too. Okay, so the entrance type, the type C1 was a box culvert, 2 is a circular. Type E is a 3, which I think might be like wing walls with like 15 to or 30 to 75. 0.012 was the culvert N, and the K was 0.5, and the base was 11 feet, which honestly doesn't make that much sense to me because my guess is that if that's a 6 by 11, kind of doesn't seem right. So it could be 2 box culverts, or it could be that width was measured by the map and it's just off by a foot. So I'm thinking 6 by 5, and that those are 2 5s, and that's probably 10. So I'm just going to change it right now. And that one is complete, so we can move to the next one. So if you click the drop-down menu, go to the next one, and you see it takes you right to it. So back over on the list, I'm going to switch to Culvert 40. And then I'm going to do the exact same process. And then I'll show you this process one more time, probably 2 more times, and then I'll just go do the rest and then I'll pause the video. So this is Culvert 40. Okay, and floodplain to floodplain. See, there's no channel in the area. I mean, it's a channel, but there's no flow 2D channel. Right, culvert equation and type 2, and this stays at 0 because it's just invert to invert. This, if it had a weir or something in here, the water had to get up and over the weir, that's when you would use this guy right here. The culvert length is 94, or let's just say 95 because it's 94.9, so let's just say 95. And 6.2 is again, this is the height, so 6. I don't think it's 6.2. These are pretty standard. They don't typically have 0.2s, so I'm just going to leave that at 6. And again, it's a box culvert, so that's a 1. The entrance type is 3, so I think that's 30 to 75 degree wing walls, 0.012, 0.5. And the base of this one is, again, 11. So again, I don't think that's 11. I think it's 10. So I'll just set that to 10 because I've never seen a 6 by 11 box culvert. I've seen a 6 by 10 or 6 with 2 5s or whatever. And that one is also finished. So we just move on to the next one, structure 3. And let's go ahead, and that one is CU27. So we got that one here. And this will be the last one I do, then I'll do the rest. Pause the video and do the rest. So we'll name it CU27, enter, tab. No. Okay, floodplain to floodplain. Rating or culvert equation. Tailwater switch set to allow upstream flow. The length is 66.13. The width is 4. Oh, I'm sorry, that's like the height. Because this is a circular. So this is a 48-inch pipe. And then over here, type 2 equals circular. And this number 2 is probably a either a flat head wall or maybe a protruding. It's in the data input manual. And then we have the culvert end. Unless that's corrugated, then it might be like a little bit higher than 0.012. So let's say that's a little bit higher than 0.012. And the cube base is 0 because this is a circular. So it's either 0 or null. I think it's null. Yeah, I think it's null. Okay. All right. So I will pause the video and we'll do the rest of these. Okay. I'm back at the one that's slightly different. So I'm going to go ahead and show you this one. So this one is CU15. So CU15 and floodplain to channel rating culvert equation. And CU15 has 168 for the length, and the diameter or the height is 6. And this one is also a box culvert, so it's not it's height in this case. So this is 1, 3 concrete box culvert, and 7. And again, I'm not quite sure where that 7 comes from. So let's take a quick look at it. 1, 2. It looks like it has. That's a bit of an oddity. Let's just measure it. It looks like it has multiple box culverts. Let's take a look at it on Google Earth. Because Google Earth has, okay, so this is, where is, here, okay, here we go. Right, here it is right here. Yeah, this isn't a very good view of it but you can see the wing walls. But let's get this back to like the most up-to-date map, because that will have the, let's see. Actually, nope, we're gonna have to get that on. We'll have to get that here. I'm gonna pause the video till I get that loaded. Okay, so if you don't quite agree with what the data says, just check the culvert out in Google Street View. Sorry about the LiDAR makes it a little funky when you get down in this view, but what I did was I just took my cursor and you can see pretty clearly that there are 3 barrels. And if you measure it back here on the map, on this distance right here is about 30 feet. So those are 10-foot wide with 3 barrels. So we can use 30 instead of 11. So this Q base is actually 30, not 7. Or you can do 10 and then you can add another variable. Well, it's not set up to do it in QGIS yet because it's brand new, but you can set up the multi-barrel feature as well. So the multi-barrel, the number of barrels would just be either 1 to, I don't know, you can have many different kinds of barrels, but in this case, it would be 10 and 3 would be the 2 variables, but you just put that 10 right after the third, or sorry, you just put that, this would become a 10 and then it would be a 3 right after it in the data file. So we'll see that in a sec. Okay, so so that one is, so that was how you set up the floodplain to channel. The only thing different about it was that it goes to that left bank and it says floodplain to channel right here. So I'm going to finish the rest of them and then we'll come back and take a look at the data. Okay, so now all of the structures are finished with their data. So a couple of things that are important. If you're going to be putting these structures in, it is probably a good idea to name them 0, 0, 1, 2, N, because if you have several hundred of them, QGIS tends to sort things like literally, and it will sort like ones right next, like the 1 right next to the 12. So if you sort that from 0, 1 through, or however many you have, or 0, 0, 1 through however many you have, that'll make that sort better if you have a lot of these. And if you, once you're finished with this, you can just click this schematize button right here, and that will convert the data from the user layers into the Flow2D layers. So now you don't typically end up with something like this where you have this shape file. I took this shape file from a Flow2D project, so that's why I have this. You might just have lines that show you where the links are, and then maybe you have like a report of all these culverts or something, or from the city that has all the information about the width and everything. Or if you are missing something, you might have to do a site visit. Now, the way that Flow2D works is that it takes the invert elevation from the map and applies it to the from the grid element, and that becomes your culvert invert elevation. Let me show you what I mean. So if we have our elevation raster here, you can see that if I use the ID tool on this grid right here, where this is my upstream cell, and oops, wrong ID tool. So hang on, I wanted this ID tool. The elevation is 1.050, and then the downstream is negative 0.19. Now, unfortunately, that's a little misleading because, this is a coastal model, so all these are full and we're not getting that bathymetry data. So if you wanted to put, real data in here, real bathymetry data in here, you'd see that, or you could put this in as a trapezoidal channel or whatever you might, but you see that there's a bit of a drop structure or maybe perhaps a gate or something right here. I also took a few of these structures out, so this one's missing completely. That's okay. And then I'm not really modeling every single channel in here. I'm just kind of like only the important ones that cause quite a bit of drainage are the ones I'm taking. So if you had a coastal model, what you're really getting is allowing the surface water that's above the water surface elevation that's taken at the point where the LiDAR was measured, and it's turning the culvert on for anything above that. So it's a little misleading in that regard. But if you don't want to put in every single tiny little channel, you're probably just going to be stuck with that. And it's okay to like show how things drain, but it's not quite as accurate as if you used like every single channel, which I don't really recommend doing anyway. Okay, so I'm going to zoom to the layer here, and let's go ahead and make, I know that the culvert switch is turned on because we already made some hydraulic structures for those weirs. So we don't really need to do anything here. I'll just turn that off. And then if we hit the export button, everything is ready to go. I'll just click OK. And in this one, we're going to export it to the culvert test. And I'll go ahead and click, I'll select folder, and we'll let that export. Should just take a second. And now what we were looking for was the highstruct.dat. And then once you export that, you'll get culvert test H. Well, let me hit that twice, highstruct.dat. So you start with your Coco 1 and Coco 2. Those are the weir tables. And then you start getting your CU culverts. And so you see here that 0 is floodplain to floodplain, 2 is generalized culvert equation. This is the upstream grid element. This is the outlet or the downstream grid element. Tailwater means this switch position is your tailwater. It means you can go upstream or downstream flow through that culvert. We don't have a head reference elevation because there aren't any weirs on any of those structures. There might be like there are some tide gates on some of those structures, so be careful about that. This is the length of the culvert. Now let me show you how you get that length. If you don't have these measurements directly from a culvert report or something, you can get them pretty easily. I'm just taking this length from right here. So I grab this tool here, and then I can set this to feet. And then I'm going to take from the head wall of the upstream to the head wall of the downstream, and that's my length. Even though my culvert isn't positioned exactly like that due to some of the elevation issues, my length is the exact length or the measured length of the culvert. So it's approximately 88 feet, this one is. And let me see, that is culvert 40. Let's see what they had in there for the length of culvert 40. Oh, they had 95. So yeah, I would say, well, let's just try it again. Feet to feet. Yeah, it's about, that's right, about 95. So that's good. So that's how you get your length, and you get your dimensions either from an as-built or maybe a culvert report if they have like an inventory of all the culverts through the city, or you can maybe do a site visit, and if that, or you can just kind of go off the standards. You know, there are standard culvert dimensions that are typical for the Collier County. So that's another great way to kind of estimate the dimensions of the culvert. And then the rest of these values come from the data input manual to show you how to set up, what is it, a box culvert or a circular culvert? Does it have, if it's a box culvert, does it have a flare or does it have wing walls? If it's a circular culvert, is it projecting or is it straight up against the head wall? Your N value and your coefficient, loss coefficient. And this, again, remember, this is width and this is height or diameter. And so if it's a diameter, if it's a diameter and there's only one barrel, this is 1. And then if you have multiple barrels, remember, that's a new feature. We haven't had the time to put it into the QGIS yet, but there's a new feature in here called multiple barrels, and it goes right after. Let's see, I'll show you. I'll grab that data file again. Now remember, we had one in here that was like 30 feet wide. Let me see if I can find that one. It should be here, this one. So in this one was 3 10-footers. So we could put this at 10 and this at 3, and it would read it. Or if it's just there, it'll just assume that's one barrel. So this one, you could do it either way. You could do that one either way and it would be fine. Okay, so I'm going to, let's see, let's just test the run. So I do not like to run from QGIS. Well, it's fine now because we updated it so you didn't get that error, lock it down. It gives you a funny message, but you can just ignore it. I'm gonna just let it get started to make sure we don't have any errors. Okay, we do have an error, so let me check that. And then this says error. The model failed. Well, no, it didn't. Obviously, it was running. There's no problem. So just ignore this message if you see that. And so let me go grab the error message. And let's see what that was. Okay. Oh, here it is. It says error. The culvert length must be signed in the S length on structure number 6. Okay, let's see what structure number 6 was. Okay, I think structure number 6 is not CU6. It's actually structure number 6. So that's 1, 2, 3, 4, 5, 6. Is that the one I changed? Oh, no, it is. It's right here. Yeah, it says no. Wait a sec. Let me read that message again. Let me read that message one more time. It says culvert number 6. It says if the generalized culvert equations are being used, the culvert length must be assigned on the S line. Oh, it's on the S line. Let's check all our S lines. Okay, so we got that. 1, 2. Oh, here it is. It's 118. Okay, so 118 should be 152. Okay, so I'm going to put that here, 152, and save that and close it. But I'm also going to fix it right here. So that was just a mistake. Okay, all right, and then I'll just hit that again. And I don't have to export it because I already fixed it, but let's. Okay, so we ran it from this time, we ran it from here, so we can do that again. And then let's wait for it. Okay, so we know it's running, we'll just leave it, and then just click OK. And then let's see, save, and oh, I'm gonna also put the culverts down here some because I'm gonna put this culvert down in the external data because we don't need them anymore. And save, and I can turn those off. Well, let's just leave them. Close, and let's get back in here and do the backup. We'll build the backup data. So right click, send to compressed file, and we'll call this Culverts OK. And then that can go up here in the backup files. And I already have one in there, so I'll just replace it. Okay, and then we'll open it back up so that we're ready for the next section, or the next thing, which is the storm drain shapefile development. Okay, so I'll stop the recording here.